What if the universe had hidden shortcuts? Not super fast space engines, not futuristic machines, but natural tunnels built into space itself. Imagine traveling across the universe in seconds, not by moving faster, but by taking a shortcut through space. It sounds impossible, but here is the part that makes this real. Einstein's equations say it might be possible, and if that is the true, wormholes would change everything we know about distance, time, and reality itself. Chapter 1: Where the idea began. Over 100 years ago, after Albert Einstein introduced general relativity, something strange appeared in his equations. Einstein explained that gravity is not just a force, it is space bending. Imagine a flat sheet. Place a heavy ball in the middle. The sheet curves. Smaller objects roll towards it. That curve is gravity. In 1916, a physicist named Ludwig Flamm was studying these equations when he noticed something unusual. The numbers allowed space to bend so extremely that two separate regions could connect not side by side but directly. Imagine space like a sheet of paper. Normally traveling from one corner to the another takes time, but if you fold the paper and makes a hole straight through it, the distance suddenly becomes small. That hole is what we call a wormhole. Chapter 2: The Einstein-Rosen Bridge. In 1935, Einstein and Nathan Rosen explained this idea further. Their model became known as the Einstein-Rosen Bridge. It described a bridge connecting two distant points in space-time. But there was a serious problem. It collapsed instantly. The tunnel could not stay open long enough for anything to pass through. So wormholes were mathematically allowed, but physically useless. For decades, they remained a fascinating idea, beautiful in theory, impossible in reality. Chapter 3: The Attempt to Make It Real. In 1988, physicist Kip Thorne and his colleague Mike Morris asked a bold question: what if a wormhole could be stable? They described what is now called the Morris-Thorne wormhole, a version that in theory could allow space travel. This wormhole would have two mouths connected by a throat, to enter one side and to exit the other side. It may be another galaxy or maybe another timeline. But again, there was a problem. To hold it open, you would need something called exotic matter, matter with negative energy, and we don't know how to create or control it. Without that, the wormhole would collapse instantly. So once again, the universe says the idea is possible, but gives us no clear way to use it. Chapter 4: Wormholes versus black holes. This is where confusion begins. Many people think black holes and wormholes are the same, but the answer is no, they are not same. Black holes are real. When massive stars collapse, they create regions where gravity becomes so strong that nothing escapes, not even light. At the center, there is a singularity. Around there it is event horizon, the point of no return. Once you cross that boundary, you cannot come back. We have detected black holes using instruments like LIGO, which measures gravitational waves from cosmic collisions. Black holes traps you, but wormholes connects you. A black hole is like falling into a deep well with no exit, but a wormhole is like walking through a tunnel with an opening on the other side. Both bend space in extreme ways. Both come from Einstein's theory, but their outcomes are very different. Chapter 5: The Strange Connection. Here is where things become even more interesting. Some early wormhole ideas actually came from black hole equations. In theory, a black hole might connect to something called a white hole. A white hole would do the opposite of a black hole. Instead of pulling matter in, it would push matter out. If a black hole connected to a white hole, the tunnel between them could act like a wormhole, but we have never observed a white hole, and no observation has confirmed a real wormhole presence. Some modern theories suggest that small wormholes might exist in a very small particle level, too small to detect, too unstable to measure, but possibly part of the deeper structure in the universe. Still, there is no direct evidence. Chapter 6: Why we have not found the wormholes. Right now, no space mission is directly searching for wormholes. They are too theoretical. Gravitational wave detectors continuously scanning the universe. Sometimes unusual signals appeared. Some people wondered if those signals could give clues about something more. But so far, every strange signal had a simpler explanation: black holes or neutron stars. So, as of today, wormholes remain in equations, not in telescopes. But history gives us perspective. Black holes were once considered unrealistic. For decades, they were only theoretical predictions. Then technology improved and we found them. Chapter 7: The Bigger Question. So, the real question is not whether wormholes sound impossible. The real question is whether we are simply not advanced enough to see them yet. If one day we confirm their existence, everything changes. Distance would lose its meaning. Travel would no longer require crossing space, only stepping through it. Time itself might behave differently. For now, wormholes remain one of the most fascinating possibilities in physics. Not proven, just waiting. And maybe somewhere in the vast universe, these tunnels already exist. They may be silent, invisible, and hidden within the fabric of space-time. And one day, we will finally discover whether the universe truly has shortcuts built into it. Join our journey by hitting a like to this video, share this information, and subscribe to Galaxora for more mind-bending cosmic space mysteries.